Looking for a fast-charging, ultra-responsive stylus for your iPad? Meet the 2X Fast Charge Active Stylus Pen, designed for 2018 to 2025 Apple iPads. Take your creativity and productivity to the next level. Click the link in the video description to shop now on Amazon.
Welcome to Bitcoin Bulletin, where we dive into the world of cryptocurrency and explore the latest trends and innovations that are shaping its future. Imagine a scenario where quantum computers become powerful enough to break the encryption behind our digital currencies, rendering them obsolete overnight. Sounds like science fiction, right? But is it possible? We're about to find out. So, let's start with the basics. Bitcoin and other cryptocurrencies have become increasingly embedded in the global financial system. Countries are creating strategic reserves, and institutional investors from hedge funds to pension schemes are allocating capital to digital assets. This means that many individuals, businesses, and even governments are exposed to price fluctuations in this notoriously volatile market. But what if a technological advance were to render these assets insecure? The consequences could be severe. And that's exactly the scenario some experts associate with quantum computing. These futuristic machines harness the strange properties of quantum mechanics to perform specific types of calculations exponentially faster than even the most powerful supercomputers. For context, Bitcoin currently uses cryptographic schemes like the elliptic curve digital signature algorithm, ECDSA, and Schnorr signatures to verify ownership and authorize transactions. These systems rely on the difficulty of deriving a private key from a public key, a task that is computationally infeasible for classical computers. But quantum computers operate on different principles. They can perform many calculations in parallel, thanks to phenomena like superposition and entanglement. In 1994, mathematician Peter Shor developed a quantum algorithm capable of factoring large numbers exponentially faster than classical methods. This algorithm, if run on a sufficiently powerful quantum computer, could undermine encryption systems like ECDSA. The core difference lies in how quantum and classical computers handle data. Classical computers process data as binary digits bits, either zeros or ones. Quantum computers use qubits, which can exist in multiple states simultaneously. And that's where the problem lies. If a quantum computer can process qubits faster than a classical computer can process bits, it could potentially break encryption systems like ECDSA. As of 2024, the most advanced quantum computers can process around 1,000 qubits, but estimates suggest that breaking Bitcoin's ECDSA encryption would require a machine with 10 million to 300 million fault-tolerant qubits, a goal that remains years or even decades away. But technology often advances unpredictably, especially now that AI tools are accelerating research and development across fields, including quantum computing. That's why work on quantum safe, or post-quantum, cryptography is already well underway. The U.S. National Institute of Standards and Technology, NIST, is leading efforts to standardize cryptographic algorithms that are secure against quantum attacks, not just to protect cryptocurrencies, but to safeguard the entire digital ecosystem, from banking systems to classified government data. Bitcoin's open-source software is managed by a global community of developers with clear governance protocols for implementing updates. In other words, Bitcoin is not static. It can evolve to meet new threats. So, could quantum computing kill Bitcoin? In theory, yes, if Bitcoin failed to adapt and quantum computers suddenly became powerful enough to break its encryption, its value would plummet. But this scenario assumes crypto stands still while quantum computing advances, which is highly unlikely. The cryptographic community is already preparing, and the financial incentives to preserve the integrity of Bitcoin are enormous. Moreover, if quantum computers become capable of breaking current encryption methods, the consequences would extend far beyond Bitcoin. Secure communications, financial transactions, digital identities, and national security all depend on encryption. In conclusion, the quantum threat is real, but so is the work being done to prevent it. So, if you're among the millions with a bit of Bitcoin tucked away in the hope it will one day make you rich, well, I wouldn't say you need to worry that quantum computing is going to make it worthless anytime soon. But you should be aware of the situation and keep an eye on developments in post-quantum cryptography. That's all for today's episode of Bitcoin Bulletin. Thanks for joining us.